Well, thanks everybody for coming. Thanks in advance for listening. 40 minutes. I'm already probably behind because I want to try to get as much as I possibly can out of this. So here's how I think this is going to go. This is my plan anyway. So there's about 3 sections to this talk. The first one is going to be a little bit of background on what I mean when I say qualitative. The second part is I'll walk through a little bit of an example, sort of in the wild, about what I mean, and then the last part I'm going to talk about what opportunities exist, what we think we can do, and I'm going to try to emphasize to you how important this stuff is. So, in keeping in line with the familiar template of thought-provoking technical talks, I will provide you with the obligatory quote that kicks off. Bootstraps are it's meant to impress you. Not everything that counts can be counted, and not everything that can be counted counts. Right? Now, for those of you who have ever worked with or in university or listened to somebody like me drone on and on about qualitative and quantitative, and maybe the relationship between the two, this is not going to be that qual versus quant, or one is better than the other. It's not going to be a simplified pros and cons. It's not going to be that. The other thing is that qualitative research isn't actually all that new. It's been a thing for decades in our field. It's just not widely known, and a specific type of qualitative research, that is to say naturalistic qualitative research and ethnography and case studies on ourselves, that is a thing that's not very well known. So here is the bottom line up front, my 2 main points that I want to support. Qualitative research in our field is at best underrepresented and at worst unknown entirely, and that we will miss out by not paying attention on fundamental evolutions of our field if we don't level up our knowledge and skills in qualitative research and analysis. Okay? Why? Why do I think this is important, and why do we think it's really hard for us to kind of wrap our minds around? Well, the fact of the matter is that most of the people in here get paid every day to make a computer do a thing that is, to some extent, repeatable and deterministic, or at least have an objective outcome. In fact, if you run the program and you get a result and then you run it again with all of the same inputs and you get a different result, it's possible that that's what you intend, but it's also maybe not what you intend. The thing is that our work, when I say work, I mean the organizations we're in, the goals we have, doesn't work like that. And so we can be fooled into thinking that numbers and quantified data, quantifiable measurements, are the way the world works. So let's talk about what I mean when I say qualitative data. By qualitative data, I mean descriptive data that is non-numerical. And that usually comes in the forms of some sort of recording or an artifact or observation of what people say and do. And these data collection, the way that this data is generally collected are usually specific forms, and there's myriads. We'll talk a little bit about that, of knowledge elicitation, what's in your noodle, observations, interviews, content analysis, about what you say, what you write. And the intent is that we want to use qualitative data because it can give us a deeper insight into how things work, or how we perceive things work, which can arguably be as important, if not more important, than how things actually work. So here's an example. So let's say this is the StatsD open source project on GitHub, right? It's my company, Etsy, had open sourced this. And here's some data, here's some quantitative data about the project, right? And this is informative. And depending on what I want to do, depending on what I'm looking for, depending on what kind of questions I want to ask, I'm interested in answering, this could give me some insight. Here's a piece of qualitative data about the project. This is from a blog post. And part of the blog post is instrumenting our application with stats D is easy, especially when we just stick to counters and gauges. Okay. This is a perspective that at the very least, the author has presented with two pieces of interest. And here's what I'm interested in. I'm interested in his or her use of the word easy, and especially when we just stick to counters and gauges. I could see this being useful in a number of different ways. I made this up, so I have no idea. I don't know what question I would use this data for, but I can imagine something like making attempts to find out what level of difficulty is experienced with implementing open source time series packages, right? It also makes me wonder, what if I didn't stick with counters and gauges? He or she obviously has an opinion there. Here's another blog post. Not only is it easy to instrument your app, the StatsD protocol is text-based and straightforward to write and read. Again, easy. This is a value statement. It's easy. I don't know what it would make hard, but the fact is that this person thinks it's easy and straightforward. What's the difference between straightforward and easy? And how would they describe what is something that is straightforward and something that's not straightforward? A couple more examples. A friend of mine, Adam, wrote a blog post a couple of years ago about he was messing about with Rust and Go, and he had lots of opinions. And so here's some things that he said. He said, the more that you understand the language, the more it feels like I can express myself in the same way I do English. So let's take a look at this. This, by the way, looks a little bit what content analysis looks like. Here's a question. When can you tell that you're understanding more of something? What does it feel like to express yourself more easily? Could we identify, maybe we could identify ingredients in a programming language in order to support people feeling that they can express themselves more easily? That, I don't know the answer. These are all, by the way, I'm going to be asking a lot of questions to which blank stares is a completely normal and a reasonable response. He says this, he says, that said, it is the first time in my life I feel like I could trust myself to write fast, efficient, low-level code. I bet anyone here could tell me a story about when they did not feel like they could trust themselves to write fast and efficient, low-level systems code, right? Raise your hand if you could tell me a story about that. Okay. So, apologies, Sam. This next slide has nothing to do with you, but it was just easy and it was on my Kindle and I was reading the book. A quick screenshot of Search, Sam's book, excellent book, Building Microservices. This could have been a book that authors who are speaking or in our field, anyone. In fact, when I've made this reference before, I can use it I can find marketing materials for tools that we are all marketed to use. What does it mean to reason about something? It's a trick question. It's a trap. Reasoning, broadly defined as a process of drawing conclusions to inform how people solve problems and make decisions. Great. That's a pithy, generally throwaway sentence. Cognitive psychologists and philosophers have been working on this about 200 years, so it's unlikely that you're all going to have a good answer. That doesn't mean that we can't get good directions from this, but reason about is a phrase that we use. It's part of our vernacular. And generally speaking, and I have said this as well, something is easier to reason about or harder to reason about. Now, and I bet that many of you, probably today, has said or heard that phrase. Now, here's what I would say. If I were to interview Smart Sam about what he meant when he wrote easier or harder to read about, then I might be able to get some more information. I might be able to get some more data if I could ask him the right questions and get good at asking questions that focus on what it means to reason within the case of microservices or within the case of the contextual bits surrounding the sentence. Maybe he could say that he would recognize cues from a diagram. Maybe I could ask him questions that might help hone in on, well, is it something about a recognition in working memory? This reminds me of something, so therefore I might be able to reason about it easier. This is called qualitative inquiry. This is it. But at the same time, when we say reason about, we generally, and I do this too, this morning in the keynote, I nod, you're like, oh, it's easier to reason about. Oh yeah, I know. Oh yeah, I know that. Can't tell you what reasoning is, but I know. Oh yeah, I get what you mean. So here's another exercise. Here's some quantitative data. I'm going to show you two pieces of computer, two pieces of code. The first one has 8 lines and 79 characters. The second one has 1 line and 26 characters. Okay, so here's the first snippet. Okay. I know it's super esoteric. You've never seen this before. I understand. I'll give you a second to sort of really grok it. Okay? Now, when I show you this, you'll read it, right? And maybe you'll pull some things from your working memory. Maybe you'll recognize something that you've seen before. And maybe you'll say, oh, I know a little bit of C, and I'll say, oh, I see how that works, whatever. Now, so here's this. Here's the second one. Now, what's interesting about this is both of these things do the exact same thing. They produce the exact same result. I'm willing to bet that your experience when reading this is different than the top one. Am I wrong? If it's the same, then whoever you are, I'm going to end the talk and you and I are going to Las Vegas because you are special. So my questions and listening to you in you describing your experience upon reading this or attempting to understand it are specific ways of doing qualitative inquiry. Billy Von Cohen, who was a professor at the University of Texas at Austin, defined the engineer in the early 80s, not in terms of the artifacts that an engineer produces, but rather as someone who applies the engineering method. And he says this. He says, the engineering method, broadly speaking, is a strategy for causing the best change in a poorly understood or uncertain situation within the available resources. It's actually quite good. And Cohen's entire book, The Definition of the Method, is really worthwhile. And of course, these words indicate normative perspectives, right? Along a spectrum or a continuum. There is a best. What has been said before is if you want correct answers, work in mathematics. We're in engineering. We work in only best answers at the time. Poorly understood or uncertain, see Dan's keynote earlier. Cohen contends that the epistemology of engineering is entirely based on heuristics. He said, engineering has no hint of the absolute, the deterministic, the guaranteed, the true. Instead, it fairly reeks of the uncertain, the provisional, and the doubtful. The engineer instinctively recognizes this and calls his ad hoc method doing the best you can with what you've got. I think you all recognize this as a quite fine, reasonable reflection on engineering. If you buy this idea, which I do, then it means that using heuristics or rules of thumb is part of our everyday lives, and this can give us some insight into what cognition looks like. Quick note here, it's a little bit of slide trivia. 1964, United States court case. 1958, around the introduction, 1958 French drama film. It was played at a movie theater in Cleveland Heights in Ohio and resulted in a criminal conviction of the theater manager for a public depiction of obscene material. He appealed his conviction to the United States Supreme Court, which reversed the conviction and ruled that the film was not obscene in its written opinion. This case resulted in Justice Potter Stewart's famously subjective definition of hardcore pornography. He said, "I know it when I see it. And this is not it." So he has a judgment. He has a view. He probably has a handful of rules of thumb in his mind about what constitutes pornography. We all also probably have rules of thumb about what constitutes reasoning about high volume, large scale, micro. Isolation, right? And these are good. These are good things. These are good words to use, but they're underspecified. That's fine, because our work then forces us to become specific. So if you follow me so far, these are some of the handful of infinite questions we can ask to gain and use qualitative research. The point that I want to get out here is that we have to try to get at this qualitative information, because our world is just messy. It cannot be quantifiable. So while quantification is an incredibly powerful and should always be part of our everyday lives, my plea to you is to reach out there in the world to some of the places that I'm going to point you to and get good at this. In messy worlds such as ours, I want to point folks to this bit, and this comes from cognitive systems engineering. And this is from David Woods and Eric Hallnagel, and what they call the law of fluency. And I'll read this to you. It says, well-adapted work occurs with a facility that belies the difficulty of the demands resolved and the dilemmas balanced. So I know, I'm lucky to know Dave Woods now, and I speak a little bit of Davish, so I will translate. What Woods means by this is that when we're doing complicated work, as we do every day with multiple goals and trade-offs and constraints and judgments, messy ones, including those that use rules of thumb like Cohen underscores, when we are successful at doing that, it's largely invisible. It's really hard for us to actually even explain how we arrived at these things. Think about the last time you typed LGTM when somebody showed you a piece of code. There's a lot that went in the gray matter. There's a lot that's behind that LGTM, and you just typed 4 characters. So these are the things that require, they're so important. In fact, many of you have paid lots of money, not just today, to see a lot of people talk about these topics. A fundamental tenet of what's now known as resilience engineering is that there always exists a gap between the way we believe or imagine work gets done and the way work always gets done. Earlier, Kate, her talk on usability and infrastructure, it was an excellent talk, and she talks about Don Norman, the design of everyday things, and one of the things that I like about that book and Norman's general view is that we would say, oh, well, here's a perceived affordance, or here's a new design, and what we want to do is we want to make it easier. We want the tool to sort of communicate its usage, that sort of thing. Okay, so well, what happens when you come to a place where, oh, well, there needs to be an improvement? Well, what do we do here? Oh, well, you just properly design it. What does properly mean? So one of the ways is to see what kind of workarounds people use. You all make workarounds because the tools we have are never complete. And sometimes you use workarounds that you don't even know. Sometimes they're maybe even sort of automatic. When you log into if you log into an instance or a container or a machine that you've never been on and you know you've got to do some investigation, do you have a favorite command you run? It doesn't matter whether, you have no idea what you're going to find. Anybody run uptime? As you're typing, right? And you're like, oh, I'm doing some work. Do you ever, are there's people in the room who just sometimes obsessively will type clear, right? Or we're like, oh, when you're thinking, wow, how am I going to work on this problem? Hit enter a couple of times. Why the fuck do you do that? It doesn't do anything. It's like on a calculator, you press clear. Why? Because the first time it wouldn't have worked? The thing is we don't know how our work happens. We definitely don't know how we succeed. Not well enough. We're now on section 2. There's no scenario where I'm finishing this talk. Quick sidebar. On anecdotes, right? That's just anecdotal is a common way of dismissing qualitative data as valuable. And the dismissing narrative data or stories is an absolute mistake. Remember, you paid a lot of money and traveled really far to hear stories for 3-4 days. It's exactly what we're here. Michael Patton, researcher on qualitative methods, says this. He says, cherry-picked anecdotes to supposedly prove a predetermined position comes across as exactly what they are, argumentative advocacy, not evidence. But the systematic, intentional, and careful recording of purposely sampled anecdotes can become evidence when rigorously captured and thoughtfully analyzed. This is the difference when you say, well, oh, I want data. And then he's like, okay, well, and then you hear a story or whatever. And he's like, yeah, but I want numbers. If you equate data to numbers, you're going to lose out. Here's what I would say on this last point. Feel free to dismiss stories and narrative all you want as meaningless anecdotes. You are free to do that. But I'm going to tell you now that your competitors are smart enough to collect and analyze them in rigorous ways. So, just saying, they might beat you. This slide is intentionally dense. The whole idea here is to give you a sense of how many different ways the qualitative data can be gathered, categorized, all of that sort of thing. These are common approaches. You may have heard of some of these. We don't have time to go into depth with them. You're likely more familiar with case study and ethnography as approaches. Case study is important, and there's a difference between, again, a story and an actual case study. And a case study does have structure. A case study has methodological integrity. It has an ideal study has analytical validity. A case study lets us study a phenomenon in its real context. This is what I was getting at in naturalistic study, especially when the boundaries between the phenomenon that you're looking to understand and the context aren't very clear. So typically, a researcher studies a case or a variety of cases of real-world organizations where they're being used, and then you can draw some sort of conclusions. I'm going to walk you through an example. So here are some different types that you might be familiar with. Accident investigation is a form of case study. Critical incidents that you can use. When I say critical incident, not just in accident investigation. I'm going to give you an example of a critical incident in the example. Market research. Cognitive task analysis, which is sometimes, and I will touch on that later, which is sometimes associated with human-computer interaction, and rightly so, is also used by companies like Procter & Gamble. And then discovering expertise. On discovering expertise, the one thing that I would say there, which is super fascinating to me, Gary Klein, who you may have read in the past. If you haven't, then you're totally missing out, is known for case studies around decision-making and where intuition comes from. And he studied nurses developing an ability and an intuition about detecting sepsis in infants without any knowledge of, without any awareness of biometrics that would lead them to that conclusion, and they're right almost all of the time. Firefighters in a house. I'm in a kitchen. It doesn't feel something's wrong. We got to get out of here, and making a decision to leave. A decision for a ship captain to abandon ship or not abandon ship. Turns out that abandoning a ship is ridiculously dangerous, and so it's not exactly an easy call. So here's the walk through the example. So last November, I finished as a master's program in human factors and system safety, and my thesis research was on the topic of heuristics and judgments made in the process of teams of engineers handling and resolving an outage. So I wanted to get at what goes on, what sort of mental shortcuts, what sort of rules of thumb and heuristics. I wanted to see if I could identify them. This is the only real domain-specific body of work I could lean on, period, when doing this research. Everything else for the theoretical foundation came from aviation, air traffic control, military, nuclear power, all of those domains. You all, this is no good. We need more of these. I'm going to skip through it. I'll just get to the case. The issue that I studied, I found an incident. I found an outage. And just briefly, just a little bit, the issue was that there was a personalized on Etsy, on Etsy.com, where I work. The issue is that there was a personalized recommended content in sort of this logged in feed, and it wasn't appearing, and there were timeouts that was going on. We were showing some generic, it was a graceful degradation where we were showing this generic sort of trending items, not items personalized for you, blah, blah, blah. And because of the stuff that is going on, the stuff that is used to produce this feed isn't, well, exactly ABC 1, 2, 3 simple. Where and how and when it came apart was not entirely apparent. Here's the punchline, is that anomaly response in this way doesn't happen the way we think that we might imagine it does. I want you to think about an outage. Raise your hand if you've ever helped resolve an outage at organizations. Okay. So, have you ever asked yourself questions? You're there. Oh my God, shit's broken. What's going on? Have you ever asked yourself questions like, what is it doing? Why is it doing that? What's it going to do next? And how did it even get in this state? Right? Right? Okay, good. Nods. These are the answers that well-known in aviation human factors researcher named Earl Weiner got when he asked in the early 70s pilots trying to understand what was going on in the cockpit with an autopilot. So I thought, well, I could probably use some of that. So what I ended up doing is using a method or an approach called process tracing, protocol analysis. Basically, you cannot get inside people's heads. You just simply can't. You can't get an understanding about what people are thinking. It's fine. You can't get it at it in any way, shape, or form. No fMRI will ever tell you. You are only making inferences. And to the extent that you can make strong inferences is what allows you to draw some conclusions. So briefly, don't worry about this. Basically, what process tracing does is taking externalizations, that is to say, things that people say, things that people write, things that people communicate during an incident, and lining it up and sort of matching it, informing what they do, okay? So we have engineers trying to get this outage all resolved, right? And they're saying stuff in IRC. And they're saying stuff. And the thing about a critical incident, the best part about doing cognitive task analysis is that in a critical incident, there's not a lot of time to they're not monkeying around. There's a focus of attention. So every utterance has an opportunity to be some signal that you can use. And so they're saying stuff. Oh, hey, what do you think about this? Check out this graph. Nobody had an idea about what mechanism was in play. Take a look at this graph. Take a look at that graph. Now, there's millions of graphs. There's millions of log lines. I can ask questions. What made you look there versus over here? So I'm seeing what they're saying. I'm also seeing what they're doing. I can see the axis. I can't get at whether they understood it, but I can see what graphs they loaded in their browser by looking at the access logs of all of the telemetry. And I can also see the commands that they ran on the servers. So I'm doing that, and then what I'll do is I will develop a coding scheme to narrow down what I'm looking for. There's a large uncertainty. It's an outage, which means that we're engaged in diagnosis. And so I came up with, this is sort of the end result, but I started to do open coding, what was known as open ethnographic coding, means effectively characterizing or categorizing what people are saying and what sort of categories I can put them in. And then it ends up looking a little bit like this. And so we've got people saying things, and these are the various bits. And what I can do is I can have another person who's familiar with both the coding scheme as well as the environment, and then I can find the how much we overlap. Okay. So then what I can do is I've got this, and I can split things out. I say, well, okay, well, here's diagnostic activity. Here's things that are within the realm of looks like diagnosis and that sort of thing. And then here's this other area. There's other type of interaction about taking action or responding. And then I can find these junctures, these like critical moments that I want to drill into. Anyway, long story. It's 87 pages. Don't worry. What I did is then I can put all of this down on a timeline. And from that, I can then make a map about how both relayed observations, hey, look at this, what do you think about that? And hypothesis generation, I wonder if it's the CDN. I wonder if it's something going on with the memcache. How it unfolded during the event. By using process tracing, I was able to make strong inferences. What I did later is used what they call queued recall and walked basically sort of individual postmortem debriefing interviews, semi-structured interviews, and then I could ask them. You can't just ask people what they did because they won't remember, or they don't have privileged access to their own cognition, so they'll rationalize why they did or said something. But if I can remind them and be super specific about it, I can get rid of what's called reactivity. Anyway, this was hugely valuable, and I was able to get at, the answer was yes, people do use rules of thumb. This was not exactly earth-shattering. And I was able to sort of identify in the data 4 different heuristics. You'll have to read this thesis to know what they are. Let's see, 8 minutes. I'm on slide 52 of 68. All right, last bit here. What I just walked you through is what's generally known as practitioner research. It is, I am in that scenario, I am a researcher within my own context. This is a thing. Julian Orr is a man that wrote this absolutely seminal text. It was 1990, first as an unpublished doctoral dissertation, and then later in 1996. He's an anthropologist. What he did is he embedded himself with photocopier repair technicians. He was at Xerox PARC. And what came from this, as he spent time with them, is information, data, and insight that had never been sort of extracted. And we could look back on this and say, oh, well, this sort of makes sense. And actually, we can kind of relate to it now. But at the time, this was hugely influential. He was studying the context, what he called situated practice. And you should read it. It's not long. It's really, it's an incredible example of what I think should be done in our field, in our organizations. A couple of things he said. He said, first, what he took away is that photocopier repair technicians primarily concerned with diagnosis. That's the majority of what they do. And they share stories like at lunch. And that was the way that they arrived at a sort of a collective knowledge. They never put blind faith in the manuals. They get these big manuals and, oh, for this model, you got to run through this checklist, blah, blah, blah. They relied on the discourse of their fellow workers. And they shared tips, tricks, techniques, their workarounds. And they also shared, oh yeah, the manual's wrong here. So they never trusted any of the documentation. They didn't discard it, but they were always suspect. And he said this, he said, when troubleshooting complex systems, technicians tell stories because of the hardest part of diagnosis is making sense out of a fundamentally ambiguous set of facts, and this is done through a narrative process to produce a coherent account. This isn't just tribal knowledge. This isn't just, oh, hey, I figured this out. When this happens, the 20,000 XL, it's the plastic bearing on the bottom part, not the top part, so just that. Well, if I'm telling you, and we're at lunch, or it's the 80s, so we're like lunching and like smoking, crazy, right? You're sitting next to us and you just see us talking. Dave Woods later called this cooperative advocacy. You now have a mental frame, a model of what you have in your mind, the pictures of this sort of attempt, and you're telling me, oh, here's how I figured this thing out. You're going to add that to your stuff, and none of it is written down. So then, where does training come from? Another book. Again, we don't have a lot of time. This is a really good book, especially if you like aeronautics and airplanes and that sort of thing. I'll just put one quote out here. Walter Vicente, this is a quote that he put in there from an engineer from the British Royal Aeronautics, and he said this: "Airplanes are not designed by science, but by art, in spite of pretense and humbug to the contrary. I do not mean to suggest for one moment that engineering can do without science. On the contrary, it stands on scientific foundations. But there is a big gap between scientific research and the engineering product, which has to be bridged by the engineer." A difference between work is imagined and work is done. Vicente goes on to say that technological knowledge in this view appears enormously more interesting than it does applied science. The book is really important, especially whether on the perspective of whether you believe, or whether it's important to believe, applied science and engineering are the same thing, but it's worth it. And if you haven't read this book, this is Diane Vaughan. She's a sociologist. And this is her seminal book on the organizational, cultural, as well as the technical events leading up to the fateful launch of the Challenger. She uses historical ethnography. It took her 9 years to write the book. She also uses an approach called theory elaboration. It is, to date, the most comprehensive account of systemic and, from multiple perspectives, conditions that existed at NASA at the time and the contractors, including Morton Thiokol, if you're into this sort of stuff. So my point to you is that we need books like this and their methods understood as much as these books, and they are not. And I think that we need to write new books that look like this for our field. And they don't exist yet. This is Don Norman. On the topic of practitioner research, he says, between research and practice, a third discipline must be inserted, one that can translate between the abstractions of research and the practicalities of practice. A book that I became recently aware of is from Donald Shawn. He says this: in real world practice, problems do not present themselves to the practitioner as givens. They must be constructed from the materials of problematic situations which are puzzling, troubling, and uncertain. In order to convert a problematic situation to a problem, a practitioner must do a certain kind of work. He must make sense of a certain uncertain situation that initially makes no sense. So being a practitioner researcher is somewhat antithetical to the idea that researchers have to be from the outside, have to be objective, and have to come as if it's a laboratory, as if it's a psychological laboratory. You know, the ones in like undergraduate that starving graduate students in psychology would, you know, give you a burrito to go to. It's not that. I'm going to skip over this. These are books that can give some insight in what I think we could do. I leaned on them heavily, especially on the one on the right. This is background, and this is a guide on how to think about this. Spoiler alert: what we do and teach at ETSI for postmortem debriefing facilitation skills, largely, if not almost exactly, is based on the critical decision method that Klein, Hoffman, and Crandall put together in this book. I was lucky enough, apparently now I am a researcher practitioner, I was asked to contribute a chapter to this book called Human Factors in Ergonomics in Practice. And there are lots of domains represented, and it's a short chapter. And one of the things that became clear to me as I was reading the other chapters, as well as talking throughout my master's program in all of these other domains, is that we have a massive advantage in that we are almost always, not always, but almost always, both the author and the user of what we build. So think about that for a second. When people land a plane, they don't just like land the plane like, oh, okay, well, that was a long flight. Yeah, hey, Lisa, why don't you just go, to the co-pilot, Lisa, why don't you just, I'll meet up at you, I'll meet up with you all at the bar. This dial over here, this is annoying the crap out of me. I got to increase the font on this. Like, that's not a thing. Doctors don't get to change how medicines are labeled. We get to do all of the equivalents of those things. So we've got an advantage that they don't. We need to take that opportunity. So quickly, last slide. I'm being blinked at. Opportunity is that by using qualitative research and analysis in a way that is rigorous, we can help reveal a landscape of where, when, and how people learn. If we understand how people learn, we can assist them in better ways of designing different types of training. It can shape the direction of tool design and other artifacts that support engineers making decisions. Somewhere, your shell aliases will indicate a direction. You could make a business model probably out of some of your shell aliases. If we understand what people struggle with, therefore making workarounds, then we can design better tools. We can help us gain insight into how engineers think about problems collectively. It's not just a person looking at a computer. Cognition is situated, and people work in teams. Software engineering and operations is a team sport, full stop, and we should look into that. So that's it. Again, we really don't have any choice. We have to get good at this. All high consequence, high tempo domains have a history of investing and understanding how they actually do work. And that is very clear to me, and we do fuck all. So we have to do this. There's a last little slide. Nancy Levison has a great book that underscores this criticality called Engineering a Safer World. The end.
Thank you. I'm lucky with this tent. You are the second one today recommending Don Norman's The Design of Everyday Things. I also recommend it to you to read it.
That's ever been written.
And we have a lot of questions, so please, if you could answer some of those.
How long do I have? How can you use the things you learned from the analysis of the communication and reactions of that outage? Very good question. Very good question. Well, again, without spoiling, this is a trick for me to tell you what the heuristics are. It's kind of a hard. The intention. You're doing this for not just knowledge's sake. You are doing this type of work to influence the design of tools, to influence the design of training, and all that sort of thing. It's hard to say without going into the thesis in depth. But if you download the thesis, you only have to look at the first page because the abstract kind of lays it out. It's hard for me to answer that within the time period. How would you counterbalance confirmation bias when listening to stories? Very good question. Via triangulation. A couple things. Confirmation bias, all biases, and all heuristics are inescapable. And they're also necessary. They're necessary for us to work. Biases should not be considered as faults. I think that if my gut says if you were asked Daniel Kahneman and Amos Tversky, they would have said that the one downside is that the set of research that resulted in cognitive biases is it has gained a life of its own and turned into a very sort of depressing situation. The fact of the matter is, we are wildly successful. Murphy's Law is wrong. Almost everything goes right. When you're doing that type of work in qualitative analysis, you triangulate. How do you solve for confirmation bias? You look for intercoder agreement, like I was saying. You look at the data. I'm not looking at one source of data. And so there are techniques for debiasing, that sort of thing. Do you have advice for untrained amateurs trying to apply qualitative analysis techniques without falling into easy traps? Yes. The use of folk models or biases. First, be very clear about what a folk model is. What I would say is those books, both Working Minds as well as Qualitative Case Studies, I will blog and tweet a number of really accessible resources for you to get a better handle, a better understanding, for you to not only not fall into those traps, but be less of an untrained amateur. And reach out. Everyone knows somebody in their family who is related to at least somebody who is a absolutely true and real psychologist or social scientist. Talk to them. Thanks for the amazing talk. Thank you for listening and saying that cool thing. How does a researcher, practitioner, CTO's work look like on a daily basis at Etsy? I don't know. What does the work look like on a daily basis? I will say that I now am armed with better questions than I did before. Reaching for better questions, that's the whole point of this talk, is for you to not leave with answers, is for you to have more questions and a want to develop better questions. In the end, that results in most of my colleagues in the executive team as across the company, I'm likely more irritating with questions now. What was your biggest engineering mistake? What do you mean by big? There's no way 26 seconds I'm going to be able to answer this. I don't.
Maybe not doing qualitative research for so many years.
Yes. That's right.
Thank you.
Yes. Thank you.
We also have a nice drawing for you from Remarker, you awesome. On the craft stage.
Oh, thank you so much for that.
If you have more questions to John, then you can find him in the breaks or in the evening on the party. Don't miss it. Find him and ask questions. Thank you so much for this amazing talk.
Thank you.